Find the value of 2024 taken 0 minus 2024 taken 2 plus 2024 taken 4 and so on until 2024 taken 2024. This question is from the 2024 UP Math Major Circles MATHirang MATHibay, which is one of the most prestigious math contests for high school students in the Philippines. Before we actually answer this particular problem, let's discuss first a more general problem that involves binomial coefficients. Recall that these binomial coefficients are called so because they are the coefficients when a binomial is expanded or a binomial raised to a power is expanded. So let's say we have here 1 plus x raised to n. Using the binomial theorem, we know that this will be equivalent to 2024, or sorry, n, for any whole number n, taken 0 times x to the 0 plus n taken 1 times x to the 1 plus n taken 2, x squared, and so on until we have n taken n, x raised to n. Now this term here, for the first one, this is actually just 1 because we have x to the 0 as 1. So we have here just n taken 0. This means that if we are looking for the value of 1 plus x raised to 2024, that's just equivalent to 2024 taken 0 plus 2024 taken 1 plus times x plus 2024 taken 2 times x squared and so on until we have 2024 taken 2024 times x to the 2024. So what if, just what if the question instead was, instead of we have alternating terms of positive and negative as well as a complete set of terms, what if we are asked with something like, what's the value of 2024 taken 0 plus 2024 taken 1 plus 2024 taken 2 and so on until 2024 taken 2024? How could we use this formula here to obtain the value of this expression? The answer is simple. We just evaluate this expression when x equals 1. So if we do this, all powers of x here will just be positive 1. So we'll just have the sum of the binomial coefficients on the right side. On the left side, we will have 1 plus 1 raised to the 2024 power, which is 2 to the 2024. Therefore, this value is equal to 2 raised to the 2024. This is the most basic form of questions involving binomial coefficients. If you look at the problem at hand, we could conclude at least three differences. Number one, it does not involve all indices. Because if you look carefully here, we have the 1s, the 3s, the 5s, basically all odds are missing. And then the second difference would be the terms or the signs alternate. We have here positive, this is positive, then this is negative, positive, negative, and so on until we have positive on the last part. And lastly, well, the last one observation for this one is, well, it's basically related to number one. It's that it only involves even powers or even indices. We only have here 0, 2, 4, and so on. So if we go back to our native form of the binomial theorem, we cannot just substitute 1 here, because if we do that, we will have all terms and we will not have alternating terms. So the question now would be, what do we substitute to the value of x so that we can eliminate this add terms here, and we will have alternating powers or alternative signs for the even powers. And the answer to that question is, or involves, complex numbers. So we recall that for the imagined number I, which is equal to the square root of -1, the powers of this are I to the 0 equals 1, I to the 1 equals I squared equals -1, I cubed is equal to uh, negative I. And this cycle repeats every 4 terms, so we have I to the 4th equals 1, I to the 4th equals 1, and then I to the 5th is equal to I to the 6th is equal to -1, I to the 7th is equal to -I, and so on. So how does this help us? So we expand, let's say we substitute x equals I. We will get here 1 plus I raised to the 2024 power is equal to 2024 taken 0 plus 2024 taken 1 times I to the 1. Actually, we have here the I to the 0, but I will not write that anymore because that's just 1. Plus 2024 taken 2 I squared plus 2024 taken 3 I cubed, and so on until 2024 taken 2024 I raised to the 2024. Again, recall from the observation that the powers of I cycles, we will have here 2024 taken 0 times 1, 2024 taken 1 times I, plus 2024 taken 2 times -1, plus 2024 taken 3 times I cubed, which is -I, and so on. And 2024 taken 2024 is 2024 taken 2024, while I raised to the 2024 power is just 1. So for this part, we can notice that we have already resolved one of the problems that we have. That's basically having the negative coefficients for the powers of, or for some terms, so some even terms for this sum. And then for 2024, we have +1. But we have not yet resolved the problem that we will have no terms involving add indices. We still have these terms. To resolve this, what we will do is we will evaluate another expression at x equals -I this time. So we will have here 1 minus I raised to 2024 equals 2024 taken 0 times 1 plus 2024 taken 1 times -I to the 1 plus 2024 taken 2 times -I squared plus 2024 taken 3 times -I cubed, and so on until we have 2024 taken 2024. Oops, I'll just write this properly. We will have here 2024 taken 2024 times -I to the 4th. If we expand this, if we rewrite the powers to remove the negative sign and simplify the terms as well, we will get 2024 taken 0 plus, this will be -I to the 1, so that's just -I. So we can write that as -2024 taken 1 times I plus 2024 taken 2. -I squared is just -1 squared times I squared, so that's -1 plus 2024 times -I cubed, and -I cubed is just negative of 1 raised to 3 times I cubed, and that should give you negative of -I. So that's gonna be +I, and so on. until we get the last term as 2024 taken 2024 times 1. Now, if we look very carefully, we note that the coefficients of these odd terms here are actually opposite of each other. So for this I, we have positive here and negative here. And then for the 3, we have positive and, so we have negative here and then positive here. Which means that if we add the two of them, 1 plus I raised to 2024 plus 1 minus I raised to 2024, we will have only the powers of, or we will only have even powers here. So we will have here 2024 times 0, but there's two of them, so this is times 2, plus 2024 taken 2 times negative 1 times 2 again, and so on, until we have 2024 taken 2024 times 1 times 2. Gets? So basically, we have cancelled out this term here and this term here, and then this term, and oops, sorry, I inserted the wrong circles, wrong terms. This is the one cancelling this out, and this is the one cancelling this out. So, although I wrote only 1 and 3, because we have mentioned earlier that this just cycles every 4, basically all other terms, all other odd terms basically cancels out. So if we simplify this, if we divide both sides by 2, we will basically have what we want. Over 2 equals 2024 taken 0 minus 2024 taken 2 plus 2024 taken 4, and so on, until we get 2024 taken 2024. And what's left for us to do right now is to just simplify this expression here. To simplify that, there are generally two common approaches. The first approach is to use the Moivre's theorem for complex numbers, or the second one is to just use of power reduction methods. I prefer the power reduction methods because that's, for me, a lot simpler. So if we do that, we first notice that 1 plus I squared is equal to 1 squared plus 2 times 1 times I plus I squared by the binomial theorem, and that's also equal to 1 plus 2I plus negative 1, which when we simplify, we get 2I. If we do the same with 1 minus I squared, we will get negative 2I. Which means that 1 plus I to the 2024 equals 1 plus I squared times 1012, because 1012 times 2 is equal to 2024, and that's equal to 2I raised to 10,012 equals 2 to the 10,012 times I to the 10,012. But note that 10,012 is divisible by 4, so its value must be positive 1. So this is times 1, so we get here 2 to the 10,012. Okay, we do the same with 1 minus I. This is equal to 1 minus I squared times 10,012, and eventually we'll get 2 to the 10,012 times negative I to the 10,012. You write it further as negative 1 to the 10,012 times I to the 10,012. This expression here is just positive 1 because we have an even power, and this one is equal to also to 1 because we have 10,012 being divisible by 4. So this expression here is equal to 2 to the 10,012 as well. Okay, so both expressions here are equal to 2 raised to 10,012. So if we go back here, we just substitute the value, that is 2 to the 10,012 plus 2 to the 10,012 over 2. We factor out the 10,012 to get 1 plus 1, which is 2, which would cancel out to leave us with only 2 to the 10,012. Therefore, the answer that we're looking for here is just 2 raised to the 1012. And that's our final answer. So this is quite an advanced application of advanced version of the binomial theorem. I hope you learned something from this video that you can make use of future applications in math competitions or exams, whatever or wherever this type of problems appear in your life. So please subscribe if you haven't subscribed yet, and thank you for watching. See you on the next one. Bye-bye.